Hello everybody and welcome back to episode 7 of my video stream in which we program an entire video game from scratch, from beginning to end, in the C programming language. So where were we? Oh, actually before I even start, I want to address a couple of viewer questions that I got last time. One viewer says, I have a question. Visual Studio Code is free and it's compatible with C more, so it seems that Visual Studio community, why opt into VSC and not VS Code? Okay, so I think he is saying that we should be using VS Code and not Microsoft Visual Studio. I mean, VS Code is made by Microsoft as well. Well, there's a couple of reasons. First and foremost, being that VS Code is not a compiler. It's a text. It's an editor basically, and it's cool. I guess let's look up. Let's look it up here. Yeah. So there's VS Code, and that's what it looks like. And you can edit your code in there, and it will highlight syntax errors and everything the same way that Visual Studio does. But here's the thing: even though you can pretty much write in any language in Visual Studio Code, you have to bring your own compiler. You still have to bring your own compiler. You can install the C and C++ extensions, so it gives you IntelliSense, debugging, and all this stuff. But you still have to install your own compiler on the back end, so you can use Clang or GCC or CL.exe from Visual Studio. You can still use those compilers. So it actually is not correct to say that VS Code has better support for C, even though maybe some of the IntelliSense and syntax error stuff is updated to maybe it has more like C99 or C11 awareness, if you will. It doesn't matter because the compiler, you still have to have your own compiler. So if you used GCC or something like this in conjunction with VS Code, then you would truly have better support. Next reason why is I've never used VS Code before, and while I'm never averse to trying new things, I didn't necessarily want to start out this video series by using an environment or a tool that I wasn't familiar with. Number three is that I've heard on what I consider to be pretty good authority that VS Code is really slow, especially in debugging and debug stepping. And even though I've never used VS Code, I'm inclined to believe that assertion, and I'll tell you why. VS Code is. Let me get rid of this. I have too many browser tabs open. Sorry. Let's go to VS Code, Wikipedia, Visual Studio Code. Alright, Visual Studio Code is a source code editor that can be used with a variety of programming languages. It is based on the Electron framework, and this I have a big issue with because I happen to have first-hand experience and know that the Electron framework is extremely slow. So that right there, if I see that, then it's something that I don't want to use because it's going to be slow. And I'll give you an example. I'll back up this. I'll back up this assertion. Xbox, PC, app, Electron, and yeah. Okay, so first, whoever runs this website, they don't they don't have a handle on CSS, I don't think, but it looks like this is supposed to be Electron, but it looks like Elector because the N got cut off, and it's Not because I'm not. It's not because my monitor isn't wide enough either. It's just a CSS problem on their side. Anyway, so the Xbox PC app is based on the Electron framework, and I have personal experience using this because when I use it to play with my friends on the Xbox while I'm on my Windows 10 PC, and when I click in that user interface, I can right click on something and it takes up to 5 seconds for a context menu to actually appear on the screen. It's actually the most sluggish GUI I've ever experienced in my life. So um, yeah, and so so it looks like Microsoft. And again, I'm not on the Xbox team, or I don't know anything about the Xbox team, but I'm just reading this article, and it says that yeah, they moved away from the Electron framework, and surprise, surprise, the app got much faster. So no shock there. Okay, that's why I'm not using VS Code. All those things. Let's see. I got another viewer question. Okay. This viewer says something I noticed a little late, but might still mention it. When I enter if true equals escape key is down instead of if escape key is down, closing the window with the escape button suddenly doesn't work. Could you explain why? Okay, that's actually it's a really good catch, actually. So let's go and find, let's make sure I'm still, yeah, I was just making sure my recording was still working. All right, so let's go find what he's talking about in the process player input function. You recall we use get async key state to check the state of the escape key, and if the escape key is pressed, then we send a wm_close window message to our window. So what he's saying is that this, as it's written, it works, but if he does this, suddenly it stops working. And let me hit play. And sure enough, now my escape key is now broken. I cannot quit the game with the escape key anymore. But if I take away this part, then the escape key works fine. So the reason is this. The reason is in the C programming language, in an if statement like this, the C language evaluates anything that is an expression is true if it evaluates to anything other than 0. If it is 0, if the expression evaluates to 0, then it is false. So the problem is, and this is sort of my fault. I could probably have written this better, because notice get async key state. Remember, it doesn't return a Boolean true or false. It doesn't return 0 or 1. So that the issue with that is if I were to write this statement, which it looks correct, but escape key is down is actually going to be some other value. This is pound defined true set to 1. So what I'm saying is let me go ahead and I'll set a breakpoint there, and I'll hit go. And well, I can't hit the breakpoint because escape key is down never evaluates to 1. So I'll set another breakpoint and I'll immediately hit it. So now I'll go to escape key is down at 0. Let me see if I can get it to here we go. I'll take this away. I'll set the breakpoint back in this area here. I just want to show you what the value of escape key is down actually is. Okay, there we go. Escape key is down now is actually negative 32,767. So recall in let's go back to the documentation for get async key state. Remember, it says the return value specifies whether the key was pressed since the last call and whether the key is currently up or down. If the most significant bit is set, the key is down, and if the least significant bit is set, the key was pressed after the previous call to get async key state. So my rationale for sort of just like writing this shortcut, if you will, was basically that regardless of whether the most significant bit is set or the least significant bit is set, either way, or if they're both set, it doesn't matter. Either way, the resulting integer is still going to be non-zero, right? Regardless of which one of those bits is set, or even if they're both set. So that was my rationale here, was that I don't care necessarily if I don't care whether the key was pressed since the previous call to get async key state. All I really care is that it was pressed anytime between the last frame and the present moment, which is why I wrote it like this. So, for example, if I literally just wanted to test the most significant bit, I would do something like this. And let's see, if I do it that way, let me run it again. If I do it that way, it will change the value. Now it's negative 32,768. Isn't that what it was last time? Let's see. No. So it's one difference, 32,767 versus 32,768. Yeah, and then of course if you wanted to test the least significant bit, you could just do that. Basically, this is a bitwise AND operator. So do I want to change from the way I have it now? Not really. Although I do want to change this because it's int 16, because we're using better data types now. So a short is a 16-bit assigned 16-bit integer. So I'm just trying to be consistent, and I will switch all my data types over to this standard int, the data types that we get from the standard int.h header file. Okay, so yeah, that's essentially why this doesn't work, and why, because in this situation we are literally comparing this value, which is 32,767, to the number 1, and it's not equal to 1, so it never executes what's inside of this if statement. So hopefully that makes sense. And also, this is probably a really good lesson to learn. It's something that we have to look out for in C programming, because even though that is true, that doesn't necessarily mean that it's equal to the actual literal number 1. It's just non-zero, and therefore C evaluates it to true if you put it in an if statement like this by itself. Okay, so that was our viewer questions. Let's get back to what we were doing last time, which is, if you recall, make sure I don't have my breakpoint still there, which I don't. Alright, now if you recall, we were trying to calculate the size of this monitor, and we were going to use that to basically stretch the entire window out to the size of the entire monitor. And this is the create main game window function, by the way. So I'm going to run to cursor here, and what I get when that happens is I get a resolution of 2048 by 1152. Both of those values are wrong, and I know they're wrong because my monitor is 2560 by 1440 or something like that. Whatever a 1440p monitor is, 2560 by 1440. Yeah. Okay, so whatever is going on here, get monitor info is returning incorrect data to me. And as I was explaining last time, I'm pretty sure it's because of this right here, this zoom level. In fact, if I change this back to 100%, let's run it again and see what happens. Oh, I gotta set a breakpoint, sorry. Run to cursor. And what did I get? 2560 by 1440. However, I changed the zoom level on purpose. I changed it for you guys because I thought it would make things easier to see. So we know, in fact, it is the zoom level that's responsible for this now. But I want to set it back to 125. And that's the thing, is we do have to fix this because we can't assume that the user is at 100% zoom level. We don't know what their monitor's DPI, dots per inch, is. We don't know what their zoom level is. We just want to make sure that we compensate for that and we get correct results regardless of how the user's monitor is configured. So I did a little research on this, and let's see. Let's go ahead and talk our way through this. So I looked up the get monitor info function. And there's our get monitor info function. And I think from here I landed somewhere on some documentation that talks about the virtual screen, and I really want to see. There was a graphic on it that I really want to show. All right, Stack Overflow. Let's see what you got. Yeah, so I think I did read this before, and yeah, I essentially got to there are these functions called set process DPI aware, and I think there's set process DPI aware context. Two different functions. So it says, okay, so this function says it is recommended that you set the process default DPI awareness via application manifest, not an API call. Setting the process default DPI awareness via API call can lead to unexpected application behavior. Set the process default. This is equivalent to calling set process DPI awareness context with a context value of DPI awareness context system aware. Let me click on this one. And again, it says it's recommended that you set the process default DPI awareness via application manifest. They don't actually explain why it's not recommended to use, and it's really annoying to me whenever they publish an API functions and they say we don't recommend that you actually use this. We wouldn't want you to actually use this, but I'm gonna first give this a try by using it. And if you're going to use this function, you need to do it before your application creates any windows. So I'm going to do that. I'm going to put it like right here, and then it takes in a DPI awareness context per monitor aware v2. There. And I'll run that, and we'll see what happens. Let's see if I need to set a breakpoint here. Okay, let's go. Set it and run it again. And now, there we go. Our width and height now get monitor info returns to us the proper resolution of our primary monitor, regardless of what our zoom level is. It was that easy. Now, my guess as to why Microsoft is saying we don't recommend that you use this And again, I don't know if this is the case, but I'm just going to guess that if you look down here, it says requirements, Windows 10 version 1703 is the minimum supported client to use this function. So that is bad, because that means that this, if I use this function, it won't ever work. It can't even run. I think it'll probably prevent my executable from running on a Windows 7 machine or a Windows 8 machine or a Windows 8.1 machine. Now, luckily in this day and age, Windows 7 is starting to finally subside, but a lot of people still use it. And I would prefer if I can make this game work on Windows 7 as well. There's no reason why I shouldn't be able to do that. It's, considering how simple of a game it's going to be, it's not like it really needs any cutting edge Windows 10 technology. So I would prefer not to lock out Windows 7 users and Windows XP users and whoever else if I don't have to. So that is probably why Microsoft says we actually don't want you to use this. We would recommend that you use it in an application manifest. So that's what I'm going to do. I'm actually going to remove. Actually, I'm not going to remove. I'm going to comment it out. And then I'm going to stop this. I'm going to go to my application manifest, which is in the project properties. And if I go down to, let's see, linker manifest file, make sure that generate manifest is on yes. And there's your manifest file. And you can do things like you can actually put it in the manifest that your application requires admin privileges, for example. This is where you would change that so that when the user double clicks on your executable or runs it from the command line, because of the presence of that manifest, which is embedded in your executable as a resource, then UAC will automatically trigger and ask for admin elevation for your program. So you can do that, but we're not worried about that right now. So make sure you're generating a manifest, and again, a manifest is just an XML document that is embedded into your executable as a resource, just like you can embed icons and cursors and bitmaps into your executable. You also embed a manifest file, and you could put various options in there that basically tell Windows, and I don't know who's responsible for it. I'm getting maybe the image loader. I don't know who reads the manifest file, but I'm just gonna pretend it's probably the image loader at this point. I don't know, but it reads it, and it triggers a set of behavioral changes based on what's in that manifest file. For example, a perfect example is if you go to the get monitor, cancel that. If you go to the get monitor info function, there will be some code in there that behaves differently depending on whether you have DPI awareness set or not. And that is why setting the DPI awareness in our program caused get monitor info to return either correct or incorrect information to us depending on what our DPI or zoom level was. So back to our manifest. Alright, so if I go down here to manifest tool, it's in here somewhere. Input output DPI awareness is what we need to change. And I'm going to do, there's high DPI aware, and then there's per monitor high DPI aware right there. I'm going to make a little side journey into my GitHub page, github.com. So I wrote this little utility that's basically like, it's similar to the Windows snipping tool. It's just, catered for my needs. It's something that I like it better than the built-in snipping tool. So you can take a snip like that, but it has a lot more tools. You can make boxes. You can make color. You can change the color of the boxes. You can change arrows. You draw arrows. You draw different colors of arrows. Oh, my favorite part though is the highlighter. it highlights things in a straight line, as opposed to, you know, the original window snipping tool. It's just freehand, and you have to try to make your highlighter straight, but it's never straight because it's really hard to make a perfectly straight line with the mouse. So my highlighter fixes that issue. Anyway, this program had a bug in it where it wasn't per monitor DPI aware. So a user, someone who used this program, contacted me, and they said, "Hey, I have a problem with this program. I have two monitors with different zoom levels on each monitor, and when I go to take a screenshot, this program actually flips the zoom level on each one of my monitors, and it basically makes this tool unusable for me." So doing the research on this right here actually helped me fix that bug. The research that I did on set process DPI awareness context, all of a sudden a little light bulb went off over my head and said, "Hey, this is exactly what I need for this SnipX program." And I put it in there, and I asked the user to test that, and he said, "Yeah, that actually does fix the issue now." All right, so now let's go back to Visual Studio. All right, so we are setting DPI awareness in our manifest file. We are going to rebuild. We are going to, and we're not calling the function anymore. We're going to run it and see what happens. We still get correct values, 2560 by 1440. That is the correct size of my monitor. All right, so problem solved. Problem solved. Okay, what's next? Let's see. We want to stretch this window out to the full size of the monitor. So I think what we should do is use the set window position function, and it takes a window handle, which is G-game window, and it takes a insert after, which I'm guessing is probably null. Let me look it up here. Let me go ahead and look it up. Set pose. Changes the size, position, and Z order of a window. Alright. Alright. Hwind insert after a handle to the window to precede. This parameter must be a window handle or one of the following values. Oh, we definitely want it to be topmost, don't we? Places the window above all non-topmost windows. The window maintains its topmost position even when it is deactivated. All right, I'm kind of conflicted about whether to go with Hwind top or Hwind topmost. I'm just going to do topmost for now. Okay, int x is going to be and remember, it's not going to be 0, 0, because not everybody's monitor starts at 0, 0, and that's why I really wanted to find the virtual screen. There, was that so hard? I don't know why Google was not finding that for me earlier. But this is the graphic that I wanted to show you. Last time I talked about how users can have their monitor set up in any sort of weird geometry imaginable, and they can flip them around, you know, have them in any order. They might have one on top of the other, one on the left, one on the right, etc. So for example, and you don't know which one is going to be the primary monitor exactly, so you don't know necessarily that the screen that our video game is on is going to be the user's primary monitor, or more appropriately, we don't know necessarily that whatever monitor the game is on starts at 0, 0. It might start at some other coordinate. So we can't just type 0, 0 here. We need to figure out. We need to write g monitor info dot rc monitor dot left, and then y will be g monitor info dot rc monitor dot top, and then the width of it is going to be monitor width, which we just calculated, and I'm guessing the next one has got to be monitor height, even though IntelliSense briefly stopped working, which it does all the time, which really annoys me. And that's probably it. No, it wasn't it. Too few arguments. I wouldn't know because IntelliSense isn't helping me. Okay, it needs flags. Set window pose. Let me go back to the flags and see what our options are. Window sizing and positioning flags. AC, defer, erase, draw frame. No, I don't want to draw a frame. Frame changed. Applies new frame styles using set window long function. No Z order. Retains the current Z order. Do I need? I feel like this one is important, but I can't remember why. Oh, I do remember why. But for now, I'm just going to insert this right here. All right, let's see what happens now. Take away my breakpoint. Okay. Now this gets us into an interesting situation where, first of all, you can see there's a sea of hideous purple that's really hurting my eyes. But as you can see, it doesn't quite fit. You can see over here on the left, I've got some space over here, and I think this is probably like window frame padding or something. And I've got it all the way around the window. You can see I can see a tiny bit of my taskbar peeking out underneath it over here, a little bit on the right. So basically this is all wrong because I don't want the title bar and I don't want like any gaps. I want it to completely cover the entire monitor. So something I'm going to do to combat that is I'm going to set window long, which basically the set window long function changes attributes about a window, and a window has all sorts of attributes, right? It has the size of its frame, the thickness of its frame, it has padding, it has a Z order, it has whether it has a title bar, whether it has a maximized box, whether it has a minimized box. All these things, they're all stored in the somewhere. All this state is stored somewhere along with the window object, and that's what the set window long function does. Is it changes that. So let's look it up. Set window long. Okay, changes an attribute of the specified window. Note, this function has been superseded by the set window long PTR function to write code that is compatible with both 32 and 64-bit versions, which we do want to do. Use the set window long pointer. That reminds me, I think I read some news just a few days ago that the newest update to Windows 10 is going to mark the beginning of absolutely no more 32-bit builds of Windows. So there will be no more 32-bit builds of Windows at all, either in client or in server. So that's kind of cool. Anyway, set window long PTR. Okay, so it looks like it's the same function. It probably just uses, this PTR is a kind of a clue to me that it probably uses some sort of pointer, uses something that's dependent on the pointer size of the machine, which is probably why it works on like 32-bit machines but not 64, or maybe the other way around. So let's go ahead and use that. Alright, so we're changing the attributes, and again it takes in a window handle, which is our G game window. Now it takes in, it asks, what about this window are you changing? Which attribute are you changing? So I think this is SW set window long. No. It's like, what am I changing? I'm changing the style. I'm going to change the window style of it, but I forget the name of this flag. GWL style. That's what it is. GWL style. Oh, it's GWL is for get window long, but it also works for, yeah, it's definitely get window long style. Okay. And then finally, what is the new value going to be? So basically, what is the new window style going to be? And I think what we're going to do is we're going to do window style overlapped window and WS visible, and then we are going to and that with WS overlapped window. Alright, so basically we're saying, I don't know, regardless of what the window style is right now, oh, I better put a parentheses over here, huh? Regardless of what the window style is right now, I'm basically going to apply, I'm going to apply overlap window and WS visible to it, and then I'm going to, this is a bitwise AND operator, which if you hover over all these are just bits. These are all just bits that I'm ANDing and ORing together. And then this operator right here is it's a bitwise NOT. It means basically I want you to, every bit that this thing is, I want you to basically flip it the other way. So what I mean by that, here's what I mean by that, is if I have 4 bits there, and basically if I apply the NOT operator to them, it turns them all into zeros. If I have 1 0 1 0, it's going to turn it into 0 1 0 1. It's going to turn it into whatever the opposite of that thing is. Another example, so if I were to say C bitwise NOT, and let's click on one of these. Yeah, and that's pretty much just telling me what telling us what I just told you. It's basically just flipping all the bits to their opposites. So what I'm doing is I'm taking away the overlapped window style, but leaving behind the WS visible style. So, and I think that is all we need to do. So when I take away the overlapped window style, it should take away the frame, the borders, so there shouldn't be any borders around the window. And when I run this function, set window position, I think that's where this frame is important here, because it actually makes those changes take effect. So let me just try and run that and see what happens. Oh, this is not as perfect as I was hoping. Is it or isn't it? I can't really tell. This is either perfect, or I might have 1 pixel of white space around the edges. I don't know. All right, for now I think we'll probably leave that, but I do want to set window long PTR. What does it return? Return value. If the function fails, the return value is 0 to get extended error information called getLastError. So if that equals 0, then it failed. Result equals getLastError, and go to exit. Now let's do the same for set window POS. Set window pose. Return value, return value. If the function fails, return value is 0, so it's exactly the same. If that equals 0, then result equals getLastError. And remember what I said last time is that when you look up the documentation for these API functions, if they don't explicitly tell you to call getLastError, then don't call getLastError. Okay. Alright, I think that does it. I think we have a properly full screen window at this point. Let's see, left, top, width, height. I don't think this will make any difference, but let me add one more flag in here. Probably won't change anything, but no. But it doesn't hurt anything either, so I'll leave it. Okay, style. Alright, so what do we want to do now? We need to, Alright, here's the other issue. I've been wanting to stretch, remember here's our little memory buffer, our back buffer is this little gray square, and I want to stretch this out all the way across the monitor, right? But in order to do that, I'm going to need access to the monitor width and height from within this function, render frame graphics, which I currently don't have, which means I am probably going to make these guys monitor width and monitor height. That means I'm probably going to make those global variables. And let's see, the data type for them. If I hover over this, long is the data type, and let's see, long. All of these are longs, which what is a long? A long is simply, well, there, long. And if you remember several episodes ago, we learned that a long, on this platform anyway, is the same width as an int, which is 4 bytes, 32 bits. And so ultimately we want this to be an int32t, because remember we're using these standard int data types because I think they look cool. Alright, so what I need to do now is I need to go back up here and make these globals. Int32 monitor width. Int32 monitor height. Okay. And now that they're globals and we know that they get filled out in the create game window function, we know that they will definitely be filled out by the first time that we get here to render frame graphics. So let's see, HDC, we have destination, and so we need to do width and height. Oh, let me think about this. This is a big, difficult API function, so. And the reason why it has so many parameters is because you can stretch just a subsection of your bitmap onto just a subsection of whatever device context you are blitting it onto, and so with that flexibility comes complexity. All right, so xdest is the x coordinate in logical units of the upper left corner of the destination rectangle. So our destination rectangle is our window, and we know it's going to be 0 and 0. So that's the upper left-hand corner of our window. So that part's right. All right, the width. All right, we already know the width is. I've got to go put G's on these global variables. G. Now I have to fix them right here. G. And then I gotta fix them right there. Okay. The width is going to be G monitor width, and the height is going to be G monitor height. And now what's the next parameter? The x coordinate in pixels of the source rectangle in the image. So our source rectangle is our back buffer, and we know the dimensions of our back buffer, which is right here, 384 by 240. So I think I should just put that right there. Game res height. Okay, and then the next parameters are source width and source height. Okay, my bad. So this should be, we're starting at 0, 0 in our buffer, right? So these should be game res width and game res height. And because this function stretches so far off the screen, I do reach a point where I want to basically put every parameter on its own line. This was a lot more prevalent when monitors were not as big and you couldn't fit as much on one line. We don't do it as much these days, and I try not to do it unless I really have to, but once the function really starts trailing off the screen, I go ahead and split it up like this. Okay, so there we have our memory. We're copying everything. Okay, so let's see what happens. Bingo. What we have now is our back buffer is now stretched all the way across our full screen window. So we essentially have a full screen game at this point. We just haven't drawn anything into our back buffer yet, so there's nothing to draw. And remember, we know that we did those coordinates correctly because we aren't seeing any of that hideous pink-purple color sticking through. We're covering it all up, which means that I think we're on the right track. Okay, so now that we have that settled, let's play with our back buffer a little bit. So our back buffer, as you know, it's a piece of memory, and it's just a linear set of memory addresses, one-dimensional number line of memory addresses. It does not have, inherently doesn't have any sort of like X or Y coordinate system. So let's try this. In our render frame graphics function, I'm going to do memset our let's see, g backbuffer.memory is the memory that we're going to set. We're going to set it to a value of 255, and we're going to set one entire pixel, which is 4 bytes, because we have 32-bit per pixel, 32-bit per pixel pixels, right? All right, so this should set 1 pixel, turn it into a white color. So we should have a gray back buffer with 1 white pixel in it. Does anyone want to guess where that white pixel is going to show up? I'm putting it at the very beginning of our memory. Let's find out. So I run it, see what happens. Okay, you can barely see it, but it's down there in the bottom left corner. Right down there. And I noticed that I can tell that this aspect ratio is kind of messed up because it's not square, it's very stretched out. So we may have to do something about that later. So what this means is, what if I were to do what did I call it again? Oh, well, okay, if I wanted to do game res width times 4, because it's this many pixels, 384 pixels times 4 bytes per pixel. So let's see what happens now. What happens now is now I have a solid white line that is exactly 1 screen width of my back buffer. So what if I wanted to draw 3 white lines? I times that whole mess times 3. And now you can see I've got 3 white lines at the very bottom of my buffer. So if I go to, I believe, ASCIIFlow.com. Okay, so let's pretend that this is our back buffer right here, and it's just full of memory. And here's the starting position. That's the very beginning of our memory. And it fills in from left to right, going this way. Actually, I don't like that arrow. I'll do it like this. It fills it in from left to right, going that way. And then if you just keep on going, it wraps around to the next line. And eventually you'll end up at the very top of the screen. You'll end up here. And this is the very end of the memory. And if you write over here, if you write past this, your whole game is going to crash. And I'll prove it to you. Say I want to fill the entire screen with white pixels. I could do it 2 ways. I could either do it game drawing area memory size, game drawing area memory size. No. Game. Oh my goodness. Game drawing area memory size. Isn't that what I just typed before? I don't know. Alright, so I'll do that. And you can see it turns the entire buffer white. Or if I wanted to do it like this, I could do game res width times game res height times 4. I think that's right. I think that'll fill up the entire buffer. It does. Fills up the entire buffer with white. And now, just to show you something, I'm going to draw that much plus one more byte. Just one more byte off of the top right-hand corner of the screen. And for some reason it doesn't work at all now. It turns it pink. And my escape key doesn't work either. My escape key stopped working. Oh yeah, the game crashed. The game totally crashed. And I can't get out of it. So stand by while I launch Process Explorer. Oh, here we go. Okay. Close the game. Okay, finally. So that actually brings up an interesting problem in that while we're making this game, I don't like the idea that if it crashes that I won't be able to see the I won't be able to see Visual Studio underneath it. Yeah, but anyway, the point is that I did crash just like I predicted. We crashed in memcopy or memset. So moral of the story is don't write past the end of your buffer or you will crash. All right, let's see what else. What else can we do? As I said before, with memset, you can only set everything to one single byte, which is not particularly helpful for us because we want to be able to set colors, right? And a color, we need to be able to copy in like 4 bytes. So for that, I think we can use memcopy. Let's see what happens. Let's make a pixel 32. And let's make pixel dot blue equals 255. Pixel dot green is off, no green. Pixel dot red is off. And then pixel dot alpha doesn't really matter at this point because we're not doing any alpha blending, so it doesn't matter if it's full on or full off or halfway in between. It doesn't matter right now, but it will matter later because we're probably going to want to do some alpha blending at some point. Maybe, maybe not. I mean, the original NES didn't do any alpha blending, but we might want to. We're almost out of time. Let's try to. This might be a good place to stop. Let's see if we can memcopy. Our destination is going to be gbackbuffer.memory. And then our source is going to be probably the address of our pixel, and then the size is going to be 4 bytes. Let's see what happens. Yeah, so again, it's really hard to see, but there is a blue pixel down in the very bottom left-hand corner. To make it easier to see, we'll do something like this. See, for int x equals 0, x less than drawing area memory size times divided by 2, x plus plus. I'm basically writing a for loop that is going to fill up half the screen with blue pixels. And this is known as pointer arithmetic, and it's very dangerous, and is why no other language except for C allows you to do it. All right, so let's see. Pixel 2. Okay, fingers crossed. We'll see if this actually works. No, it doesn't work. I crashed. I crashed. So annoying. Alright, game B. Where's game B? Where is game B? There you are. Kill. Process. Oh my. What did I kill? Okay. Stop. That is super annoying. Hold on. Stand by. We're going to make it work. We are going to make this work. Hang on. First thing I'm going to do is I'm going to change this from topmost to top. I think that way I'll at least be able to get windows on top of it, of our window, which is, let's see what happens now. There, perfect. So from changing the window, by changing the window from topmost, at least now when it crashes, I can see Visual Studio underneath the game. And that's very helpful. So I'm definitely going to keep it like that. Yeah, it's basically telling us that we crashed here because we are writing to an invalid memory location. So let's go back over here. Let me think about this. What am I doing wrong? Yeah, that's still 4. Nope. Alright, let's see, maybe we can just draw 100 pixels. Okay, there we go. Now I have a line down here at the bottom of the window that is 100 blue pixels. Drawing, area, width, game res. Width times game res height. There. Now I've filled up the entire buffer with blue pixels. And I think that brings us to the end. Yep, we are a few minutes over. So I think we made pretty good progress today. We have a full screen game, which is what I'm going for. Again, I've said this before, but I want to reiterate that I'm basically trying to emulate an NES or an early generation console experience where we're going to pretend that we don't have a multitasking operating system. Our game is going to be full screen, and there's going to be, that's it. It's going to be full screen, and there's not going to be anything else running. So yeah, so there's that. So we made a lot of progress. Um, all right, so as always, thank you for watching, and if you have any questions or comments, please comment on the video, and if they're interesting, then I will definitely talk about them, talk about your questions or comments in the next episode. And that is all for today. You can also find me on Twitter at Joseph Ryan Reese, and I will catch you on the next episode. See you later.